This is part 2 of the 6.05 mole volume relationships. So I want you to add to your notes this final main idea. At STP, 1 mole equals 6.022 times 10 to the 23rd atoms equals 22.4 liters of any gas. It's very important to remember. Okay, let's work through some problems. Again, I cannot stress enough the fact that you can't just watch me do it. You should hit the pause button. You should do it. Then check the answers. And if you're not there yet, then you should follow along with me. You should be writing stuff down and then go back and try again because it's the only way to get these is to practice. So, number 1, you have 15 liters of ammonia for a reaction at STP. How many moles do you have? What do you write down first? 15 liters. Put it over 1. What has to be on the bottom of my next fraction? Liters. What am I converting to? What do I want my answer to be? Moles. And how many liters are equal to 1 mole? Again, it is at STP, so we can use our 22.4. Put it in your handy-dandy calculator, and the liters cancel off, and you get 15 divided by 22.4 liters, and you get an answer of 0.67 moles. All right, question number 2. If you want, go ahead and do all these problems, and you can look up the answers right in the lessons if you're at that point. Number 2, you have 2 liters of helium at STP. How many moles do you have? What do you write down first? 2 liters. Put it over 1. What has to be at the bottom of your next fraction? Liters. What's on the top of your next fraction? Moles. Again, what is our conversion? 1 mole at STP is the same as 22.4 liters. Again, put in your calculator. 2 divided by 22.4 is 0.09 moles. All right, let's do the next one. You need 1.5 moles of ammonia for a reaction STP. What's the volume of ammonia you must use? What do we start with? 1.5 moles. What has to be on the bottom of my next fraction? Has to be moles because the moles have to cancel. It's all about canceling. If you're not canceling off your unit, you're not setting up your fractions correctly. So that's what you want to look for, that you're doing the canceling off. All right, and 1 mole is the same as what? 22.4 liters. This time you're multiplying 1.5 times 22.4, and your answer is 33.6 liters. All right, let's do another one. You have 0.3 moles of helium at STP. What's the volume? What do we write first? 0.3 moles. Put it over 1. What has to be on the bottom of our next fraction? The bottom of our next fraction has to be moles. And that's equivalent to 22.4 liters. So you multiply 22.4 times 0.3, you get 6.72. All right. The next page, a bunch more questions. At this point, I'm just going to expect that you hit the pause button. So, and, go through, do all of them. So make sure you hit pause because then I'm just going to uncover all the answers. All right, and so here are the answers. For number 1, 1.8 moles is on the bottom again, and your answer is 40.3. Next answer, 4.45. Next answer, 2.23 moles. And the last answer is 0.02 moles. If you got any wrong, look back at your work. Why did you get it wrong? Did you put it in your calculator wrong? Did you put the wrong thing on top of the fraction? Did you forget to cancel? Are you writing down moles and liters every time? I don't know why. Nobody likes doing that. It's so silly because it takes a second to do it and it really helps. So force yourself to write the units all the time. It'll make it easier in the long run. It is important to understand mole to volume relation in the context of stoichiometry. If the reactants or products are gases, which are easily measured in liters, then you might have to convert liters to moles or moles to liters. But again, the reaction must be at STP for that to work. Because remember, if you have more pressure, it's going to squeeze those molecules together, so it's going to take up less space. If you have a higher temperature, those molecules are going to have more energy and take up more space. So that's why the STP is so important. Also understand that a mole of any gas always takes up the same space at STP. However, moles of different gases will vary in mass, depending on the composition. So that's where we talked about 1 mole of oxygen weighs a lot more, 16 times more, than 1 mole of hydrogen gas, but they take up the same amount of space because the gases are bouncing around so much, there's so much empty space in between the molecules. And molar volume is used to convert between moles and volumes of gases at STP. Gases are often reactants and products in chemical reactions. Sorry, guys, I have a head cold. The volume of a gas is easily measured, but it changes with pressure and temperature. Chemists agree that standardized temperature and pressure, STP, is 0 degrees Celsius and 1 atm, or atmospheric pressure. Avogadro showed that at the same temperature and pressure, equal volumes of gases contain the same number of molecules. So that's what this line is. 1 mole at STP is the same as 22.4 liters, is the same as 6.022 times 10 to the 23rd gas molecules. At STP, 1 mole of a gas occupies 22.4 liters and contains exactly the same number of particles, which of course is, everybody, 6.022 times 10 to the 23rd. Use these equations to convert between moles and volumes of a gas at STP. So again, you can memorize this, but honestly, I think it's so much easier just to say, okay, what's on the bottom of the next fraction? Cancel off my previous unit. As always, if you need help, let me know.